Okay. Okay. One of the things in chapter 2 that I didn't cover was called formulas. And there's two ways we use formulas. Okay. The first way is what I term straightforward. It's write the formula, plug in, solve. Well, I'll do it this way. Those would be the steps. That's just straightforward. Write down whatever formula it is, plug in your numbers, solve the sucker. So here's an example, okay? The perimeter of a rectangle is 86 inches. If the width is 13 inches, okay, I'm going to make this a two-part problem. A, find the length, and B, find the area. So, problem we're going to work on. This is an example of what I'm just calling straightforward. Okay, find the perimeter of a rectangle, or the perimeter of a rectangle is 86 inches. If the width is 13 inches, find the length. So the way I would urge you to solve this is first, what's the formula for the perimeter of a rectangle? Well, I'll put these up. Usually they give it to you, but it's 2 times the length plus 2 times the width. That's the whole formula. The perimeter of a rectangle is 2 times the length plus 2 times the width. Okay. Think about a rectangle right here. Okay. You've got a length, you got a length, you got a width, you got a width. The word perimeter means the distance around the outside. So technically you have the perimeter is width plus length plus width plus length, if you just add up as you go around. But if we combine like terms, you get that formula. So what can I plug in? Well, I know the P is 86. Okay. Equals 2 times L plus 2 times 13. This is the plug-in step. So you start with the formula and you plug in everything you have. Okay. 86 was the perimeter because of that, it said. It told me the width was 13, so I plugged that in. Okay. And I'm done. It says find the length. So look at this equation that I just created. If I solve for L, if I use my equation techniques and solve for L, I'll answer the question. Well, so this is 86 equals 2L plus 26. 2 times 13 is 26. Okay, finish it off. We're going to take 26 away from both sides. That's going to give me 60 is 2L. 86 take away 26 is 60. Divide both sides by 2. And I get, 30 equals L. Okay. But if you give me that answer, you're wrong. Because since this was a word problem and it used inches, you say something like the length is 30 inches. Okay, you need to use your units there. 30 isn't good enough. 30 inches. You need to always imply or give back your units. So that's the first half of this problem. You just take whatever formula they give you, and then you plug in whatever was given. So this time I gave you the perimeter and the width, and then you had to use your algebra skills to solve for your length. And then always answer with whatever units there are. Is that okay with the first part for finding the length? Anybody have any questions or concerns or comments? No. Okay. By the way, I want to, Mitchell, I want to pick on you for just a second. Please, there's never a dumb question. I know every teacher says that, and you go, yeah, sure, buddy, yeah, blow it out, or whatever. Okay. But really and truly, if you're asking the question, I honest to God believe somebody else needs it also. So ask the question. It's never dumb, ever. Okay. All right. So no questions on the first part of taking this word problem, finding the length. Is that okay? All right. I don't hear anybody yelling. Find the area. Well, the area. Okay. That's another formula that you should know, and I'm going to list these, but we know that the area, okay, when I tell students, I say, okay, what's the formula for the area? They all say length times width. And I go, no, that's wrong. Okay. A formula has A equals length times width. A formula has an equal sign in it. The area of a rectangle is A equals length times width. Okay. The area or the perimeter of a rectangle was P equals 2L plus 2W. See, because if you didn't put the P down, you wouldn't know where to put the 86. You put the 86 in place of the P. Okay. If you don't put the A equals, you wouldn't know that this is the area. Now, you probably would because you're all pretty smart, but a formula is the whole thing. A equals. Okay, enough. So this is A equals the length we just found was 30 inches. The width they told us was 13 inches. Okay, so the area is 13 times 30 or 390. You could use your calculator. Notice something. Okay, I want to show you something here. Does everybody know what x times x is?
Square x.
Yeah, it's x to the second power. And like z times z is z to the second power. Well, guess what? Your units do the same thing. Inch times inch is inches squared. Old fashioned, we used to write this as 390 square inches. This is the more modern way, okay, more science way. This is the old fashioned way your parents probably learned. Maybe you learned it too. But whatever, when you're multiplying your units, they multiply just like variables multiply. An inch times an inch is an inch to the second power. All right, so I'm kind of done with that formula. I'm done with that word problem. Are we okay or not okay? It was two parts. First, we found the length. Then we used the length to help us find the area. We okay? All right. Before I go to this, another type of problem here, I want to list the formulas that you kind of need to know. Now, sometimes mom will give you the formula and sometimes she won't. And I know in future math courses, they won't always give you the formula. But let's take a rectangle. The perimeter Perimeter is 2 times the length plus 2 times the width. The area is length times width. So for all of the rectangles that we're going to run into, and a rectangle, by the way, also could be a square. A square is a special rectangle. Okay, that's the formula for the perimeter. That's the formula for the area. Okay, triangle. The perimeter is stupid. This is when you look up a book, look up on the internet, and go, what's the formula for the perimeter of a triangle? That's what you're going to see, because there is no formula. It just says the perimeter is add up the 3 sides. That's what that means. Okay. There is no real formula for the perimeter of a triangle. It's just add up 3 sides. But there is a formula for the area of a triangle. The area of a triangle is, there's 2 of them, depending on what you've been taught. 1/2 base times height, or area is base times height divided by 2. These 2 are the same. Area is 1/2 base times height. Okay. Think about this for a second. Okay. If we take a rectangle and we say this is the base and this is the height, then the area of this rectangle is base times height, length times width. But if we take a triangle, if we cut this in half, then a triangle is literally half of a rectangle. So the area of a triangle is half the area of the rectangle, because you just take that rectangle and chop it in half. That's where that formula came from. So this is kind of related to that one. Last one that's kind of important for all of us, and that's a circle. Okay. The perimeter of a circle is called the circumference, and it has 2 formulas. It's either pi times the diameter, pi d. So instead of perimeter, we say circumference. It means the same thing. Circumference is pi times the diameter, d is diameter, or circumference is 2 times pi times little r. So in this case, d equals diameter, and little r equals radius. And pi, okay, is approximately 3.14. Pi is that special number, 3.14. So that was the perimeter of a circle. Okay, the perimeter of a circle. The area of a circle is pi times the radius squared. Pi r squared. And again, to calculate it, your Aunt Sally comes in, your PEMDAS, you have to do the radius squared first, then multiply it by pi. Now, there's one more formula that I'm not going to quite worry about tonight, but guys, these come up so often in so many word problems across so many different curriculums that you really have to know these. You really and truly do. Okay, you really, really, really do. I can't stress enough. Usually, mom will give you the formula, but in future classes they won't, and you absolutely have to have this. Now, there's one more formula that I want to show you, and I want to do one more word problem or one more problem on. And that's called the Pythagorean formula. Okay. Pythagorean. Some of you learned it as a formula. Some of you in your high school learned it as a theorem. The Pythagorean formula or Pythagorean theorem. And it only applies to right triangles. Okay, it only applies to right triangles. Well, what do we mean by right? Okay, a right triangle has a right angle there, a 90-degree angle. So whenever we talk about Pythagorean formula or theorem, we're talking about this kind of triangle. Now, to get technical, the two sides that make up the right angle are called the legs. This is leg. This is a leg. Leg, leg. The two legs make the right angle. The side opposite the right angle is called the hypotenuse, Hypotenuse, which no one knows how to spell. So the best we come up with is we abbreviate it HYP, H-Y-P. And don't sweat it. I'm not going to ask a spelling test, just that it's the hypotenuse. But the hypotenuse is always the side opposite the right angle. No matter how we draw this, no matter how we twist this in space, the hypotenuse is always the side that's opposite the right angle. And the legs are always the two sides that make the right angle. Now, again, okay, here comes Foster being all proper and snooty. The correct math formula is to say leg squared plus leg squared equals hypotenuse, hype squared. The correct way to state the Pythagorean formula is to use the words leg and hypotenuse. Leg squared plus leg squared equals hypotenuse squared. Okay? Hypotenuse is always out here by itself in this formula. The hypotenuse is by itself. In high school, when we introduced this, they said, oh, this is A, this is B, and this is C. This is leg A, this is leg B, this is leg C. And so they taught you A squared plus B squared equals C squared. And if you learned it that way and want to keep using that, that's just great. I'm going to keep pushing the proper way because I like the vocabulary and I like the way that it shows you that the hypotenuse is out here all by itself. Okay, so I'm going to do a Pythagorean problem in just a second. Okay, to show you how the formula works if some of you haven't seen it or forgot it a little bit. But these are the formulas you have to have. You have to know them eventually. Okay, so I really encourage you maybe to put them on a 3x5 card and check yourself with flashcards or something like that. This is the Pythagorean formula. You do need to have it. We're going to come back and revisit this, oh golly gee, at least a dozen different times this semester. This is going to be one of our main formulas. And for what it's worth, when you get to Math 104, which is supposed to be the next course that most of you are taking, Math 104, trigonometry, it's based almost entirely on this concept. The trigonometry, the beginnings of trigonometry, everything you learn for, I would say, the first 8 weeks of the course, assuming that's half of a semester, is based upon this right triangle. They just use this concept over and over and over again in ways you've never imagined. So the better you've learned it and memorized it and can use it, the better off you're going to be. Okay, before I do a problem, anybody need any clarification on what I've been talking about here? I've been talking a whole lot. Anyone? Wait a minute, participants. Is Ann here? Nope. Okay. No questions? Okay. So the hypotenuse of a right triangle is 13 centimeters. If one leg is 5 centimeters, A, find the other leg. B, find the perimeter. And C, find the area. All right, I'm going to pause this because several of you know the Pythagorean formula ahead of time. So I'm going to pause and give you about a minute to work on this. All right, so let's draw a picture of this first. So we have a right triangle, and your drawing does not have to be perfect or anything like that. It's just a right triangle, so it's got a right angle. Okay, it says the hypotenuse, which is opposite the right angle, is 13 centimeters. One of the legs, and it doesn't matter which one, is 5 centimeters. So I'll put the 5 here. And we want to find the other leg, which we'll call X, because we're all in math and we're all very boring and unimaginative, because that's the only variable we can think of. So that would be a good start. I've drawn the picture, okay, putting the 13 on the hypotenuse, 5 on one of the legs, X on the other leg. So the formula says leg squared plus leg squared equals hypotenuse squared. So I have 5 squared plus X squared equals 13 squared. Okay, this is 25 plus X squared equals 169. Use your calculator. 5 squared is 25. Everybody should know that. But 13 times 13, that's not a common one. Is 169. Okay, we're going to subtract 25 from both sides. And we're going to get X squared equals, I believe that turns out to be 144. Now, we have to introduce a new concept. Again, if you've seen Pythagorean formula before, then you already know this concept. Everything in math has something that cancels it out. Everything in math has something that cancels it out. Okay, we have addition and subtraction cancel each other out. Think about all the equations we solve. If you have plus 5, then you minus 5 to both sides. Okay, multiplication and division cancel each other out. Okay, we've used those again in equation solving. Everything in math has something that cancels it out, has something that cancels it, undoes it, reverses it. Well, it turns out that squaring and square rooting cancel each other out. Squaring, power of 2, and square rooting cancel each other out. And there's many, many more, and we're going to study these a lot this semester. But if you have x squared and you want to cancel the square power, you tell yourself, oh, I'm going to square root this side, and I'm going to square root this side. Again, we're doing the same thing to both sides of the equation. Okay, so I knew that if this is x squared, the square root cancels it out, but I have to do the same thing to both sides. So I get x is, okay, use your calculator, or many of you already know that the answer is 12. Okay, so we found the other side leg is 12 centimeters. Boom. So what do I have here? Okay, this was 5, this was 13, this is 12 centimeters. Okay, that's what the drawing is now. I've gone back and kind of used that fact to help me make a more accurate drawing of my triangle. So I did the first thing, find the other leg, 12. Find the perimeter. Well, the perimeter is pretty easy. The perimeter is just 5 centimeters plus 12 centimeters plus 13 centimeters, which I think adds up to 30 centimeters. So the perimeter would be 30 centimeters. So let me check my math. Did I do that one right? I think I did.
Yeah.
Yep.
Yeah, okay. Notice my units, centimeters. The area is half times the base times the height. So it's half times the 12, which is the base, times the 5, okay, which is the height. So again, on my calculator, that turns out to be 30. That's wrong. If you write down 30, you do not get full credit. 30 what? 30
Centimeters cubed.
Centimeters what? Which one of these was centimeters? The half was not a centimeter, but this was a centimeter. This was a centimeter.
Centimeter squared.
So it's centimeters squared. Okay. The half was just a plain old number. But this was a centimeter. This was a centimeter. So centimeter times centimeter was centimeter squared. Okay. There's a word problem. Again, with a formula. We gave you a formula. You just plug in your numbers, solve them somehow. Okay, I want to move on to other stuff still related to formulas, but a little bit harder. Any questions on Pythagoras or anything I've said on formulas? No. All right. So remember, I wrote up here chapter 2 formulas, and I said the first thing is what I called straightforward. You write down the formula, you plug in, and then you do your algebra. That's what this was. We wrote down the formula, we plugged in, we did our algebra. And because I'm a jerk, I added extra steps to it at the end. Okay, but that's basic it. Now we're going to move to a little bit more difficult problems. Can I erase this? Is anybody still copying? Does anybody want to ask a question before I erase?
I'm good.
Okay, there you go. Okay, this is formulas. And this is called rewrite. I'll explain what I mean in a minute. Before, we were just doing arithmetic. We're plugging in, solving an equation, doing arithmetic. But what if I gave you a formula? Let's take an easy one. Okay, well, let's take this. P equals 2L plus 2W. And I said, I want you to solve for W. That's what the directions were. Solve for W. Well, the first thing we have to understand is, what does that mean? When we say solve for W, we mean get, oops, can't write it, can't talk and write at the same time, get W alone. So when we make the statement, when we say solve for W, we're really saying use your algebra skills to get the W by itself. So you're going to move everybody and their mother over to the other side and have W all by itself. All right. Well, how do you do that? Well, I'm first going to do it, and then we're going to talk about it. Okay, so let's take the problem. P equals 2L plus 2W. First thing I'm going to do is take away 2L from both sides, because I want to get rid of this 2L here. Remember, I want to get the W by itself. So I got to get rid of a bunch of junk. I got to move them out of the way. So the first thing I'm going to do is get rid of the 2L. So I take away 2L from both sides, but here's the catch. Here's the algebra. Can you actually do P take away 2L? Is there an answer to that? No, I don't know how to do that. So in algebra, we simply write that we tried to take it away, okay, from P take away 2L. We just couldn't. That's the best we can do. Okay, but what we've done is gotten the 2W isolated. Now we've got to get rid of the W, the 2. Because remember, we're going to solve for W. We're going to get W by itself. Okay, so we want to get rid of the 2. Well, the 2 is multiplying. So we know that we can divide. We know that multiplication and division cancel each other. They're called the inverse operations of each other. Again, can you divide 2 into P? No, don't know how. Okay, I can't go 2 into the whole fraction. And by the way, you cannot split that fraction up. So you end up with P minus 2L all over 2 equals W. Okay, this is the answer to the problem that I just asked. Solve for W. Get the W by itself. I took away 2L from both sides. Then I divided both sides by the 2 to ultimately get W by itself. So this is what the answer would look like. Okay. Now, let's open it up to some questions first, and then I'll do some more explanation here. Anybody have any questions on what I did, how I did, why I did it? Okay. A lot of times students look at this and they go, oh my God, I don't even know where to start. Okay. So what I try and encourage students to do is off to your scratch paper, make up numbers, just arbitrarily make some numbers up. Okay. If this was a high school class, I'd say, what number do you want P to be? And, all my little 9th grade boys would write that. Okay. So, to me, this made up problem is real similar to this formula. P equals something plus 2W. P equals something plus 2W. So then I'd ask myself, okay, well, in this problem, what would I do? What would I do in this problem? Oh, I'd take away 5 from both sides. Okay. Now, it turns out that we can take away 5. We can do 69, take away 5. Okay. But this guides me. This tells me, what do I do? This helps me to see, oh, I'll take this away from both sides. So over here, I took it away from both sides. So this made up problem is acting as my guide. It's giving me hints what to do. All right. So this is 69 take away 5 is 64 equals 2W. Now remember, I couldn't actually do P minus 2W, so I had to write that down. So I look at this problem. What would I do over here? Oh, I divide both sides by 2. Okay, divide by 2, divide by 2. So that means on this problem, on my related problem, I'm going to divide both sides by 2. So again, when students come back, they tried their homework over the weekend, they go, I have no idea how to do this. I'm lost. And I will tell you over and over, make up a related problem. Put numbers in for everything but your one variable that you wanted. Put numbers in for that, for everything. And then solve this problem one step at a time and do something similar to it in the actual problem. Okay. Before you panic too much, the ones I'm going to give you on the mom quiz for chapter 2, which is next week, not this week, next week, so relax. And on the exam number 1 are going to be pretty straightforward. I'm not going to try and trick you or anything like that. But we will keep revisiting this concept throughout the course. We will have formulas that you've never seen before that we will have to manipulate. Given a formula, we'll have to take it and turn it into something else. So you do need to practice this. This is foreshadowing for future stuff. Okay, I want to do one more problem and then move on to a different topic. So how are we on, given a formula, can you rewrite it?
I think so.
Okay, we guys
Yeah.
ready to try just one more and see how you do?
Okay.
Okay. All right, boom. So here's a formula from banking. I equals P plus P R T. Okay, and by the way, PRT, what do we know from algebra? If we shove 3 things right next to each other, what are they all doing to each other?
Multiplying.
They're all multiplying
Fine.
eventually. Yeah, timesing. So here's the formula. I want you to solve for T. That is, get T alone. I'll pause while you guys work on that for just a second. Okay, so I've got something like 17 equals 6 plus 6, I don't know, ST or something like that. I'm going to do, or let's not make it S. Let's make it XT, something like that. Okay, so I see this is my problem, but this is my related problem. Because if I look at this and go, I don't have a clue what the hell I'm doing. So I look over here, what would you do? Well, I'd probably take 6 away from both sides. And that would give me 11 equals 6xt. Okay, so what is 6 over here? Well, it's this P. I'm going to take away P from both sides. So that gives me I minus P equals PRT. That would be my first step. Now, next step, I'm looking here and I want to get T by itself. So I want to get rid of 6x. So why can't I divide by 6x? Remember, these are all being multiplied. So the thing that undoes multiplication is division. Okay, so if I divide by 6x, I got to divide this side by 6x, whatever that is. So now look over here. I want to get T by itself. So I'm going to divide this side by PR and this entire side by PR. Okay, so cancels out. I have I minus P on top. I have PR on bottom equals little t, and that would be the answer.
I have a
That's
question.
Yeah, shoot.
Why do the p's not cancel each other out? Because wouldn't that be equal to 1?
Okay, yeah and no. If you split this up and you divided each one of these individually by PR, if on this side you decided to divide each of these individually, oh, this is PR, come on, idiot, PR, by PR, okay, then you're right, these P's would cancel out and you get I over PR minus 1 over little r equals T. The P's would cancel out to leave a 1 on top. But because I left this as just the big giant numerator, the P has to reduce with the P and the I, and we don't know if it does. So because I left it as one big giant fraction, the P doesn't cancel into the numerator. But if you decided to separate it into two little baby fractions, then you could get some partial canceling here. Okay? Kind of okay?
Yeah, that makes perfect sense.
Okay.
Yeah.
All right. How's that for everybody? Okay. I think right now you have enough to go after section, what is that on chapter 2? I skipped it a while ago. 2.4 or something like that. No, is it 2.4? Whatever it is in MOM. That's something I kind of skipped over for a while. You have enough to at least get started, come back tomorrow or on Tuesday with some questions on it. But these are formulas. Okay. To be really honest, I spent way too much time tonight compared with the number of questions I'm going to ask you. Maybe 2 or 3 questions at most on the quiz, 2 questions on the exam number 1. I mean, not a whole lot at all. But you want to be able to do MOM, so here you go. Okay, speaking of MOM, I want to do something. Share, basic. Okay. Can everyone see my MOM screen?
Yes.
Okay.
Yeah, we
Yes.
can.
Good. This isn't going to work as a student because if I go into student view, what I want to show you won't work because me, the student, doesn't have a grade. Okay, so I have to go in to the grade book, but I have to go in as the instructor. You can go in as a student. We're going to go into the grade book. And because here it says invalid student ID because Larry Foster, the student, doesn't exist. But if I go into the grade book, oops. Okay, as the instructor, you'll get to see what I want to see. Okay, you're going to do the same thing. I get to see all of you. Okay, now, first thing I want to make sure you guys all know, all of this is a bunch of bull. I don't use mom for grades. So the fact that somebody has 11.7% and all that, that doesn't mean anything. I'll explain my grading next week after we take the quiz. Okay, but this is nothing. Don't panic. This means absolutely nothing in the big scheme of things. But what we're going to do here is where it says quizzes, and you'll be able to do this. You hit expand. And what that does is shows all the possible quizzes that we're going to take or have taken. Okay. Now, I can see these because, again, I'm the instructor. Okay. You can't see them yet. But when we have 3 and 4 quizzes, you'll be able to see that. So if you hit expand, and then you find it says mom input quiz, you can see your grade right down here. Okay, and you can see how you did. I don't want to do it too quickly because I don't want you to see everybody's grade. Okay, but that's how you can see what have you done on a particular assignment. You could do it on assignments too. If you want to see, okay, what have I done or not finished on all the homework assignments, you hit expand and it tells you what problems you haven't done yet, or hit collapse and it brings it back in. So in mom, let's go back. In mom, if you hit grade book, okay, we'll have assignments and quizzes. And if you want to get more information, you can expand that out to see all of your assignments. And quizzes, you can expand it out to see all of your quizzes and how you did on a particular quiz. Okay, so that's how you can always check your grade in mom, see how you did. So everybody should be able to see how they did on the quiz the other night. The quiz the other night, or Sunday night, I should say, is now open. You can go back over and do that again and again and again. Now, you can't change your score. You can't change your score, but you can practice some of those and make sure you understand what you were doing and what you did wrong. All right, let's go back. Okay, new share. Advanced. Okay. I'm back to my screen. Let's get going in chapter 4. I guess that's what we'll do.
Mr. Foster, I've got a quick question for
Sure.
tomorrow's quizzes.
Go ahead.
We are having view attempts for each question, or you get it wrong at first, it's blocked. Or we can try
Wait a minute.
3 times like assignments.
Oh, on the quiz? The quiz is, I don't even remember how many times you get. Let me write that down. On the homework, you could do it over and over and over again until you finally get it right. On the quizzes, I forget what my settings were. Quiz tries. I don't know. Ask me again tomorrow night. I will look that up after class tonight, or after class. If you want to stick around, we can go in and see my settings.
Okay, thank you.
Yeah, but if you don't stick around after class, that's fine. Just bug me again tomorrow night and I'll let you know. Okay?
Sure, thanks.
All right. Yep. Anybody else? Okay. Now, we're going to start chapter 4 right now, but we need some background. And this isn't actually in the book yet. So take careful notes and we're going to talk about this. The concept is called a function. It's called a function. And a function is a math rule that changes the value of an input number. Okay. A math rule that changes the value of an input number. We have three views of a function. I'm going to leave some room because I'm going to come back over here and talk about the three views. Leave some room in your notes for me to explain what the three views are. But let me give you the basics right now. Generally, we write something like this. Okay. And we say in English, f of x. The word of is very, very important. We say f of x is or equals this thing. It is not f times x. It is not. Okay. The way you interpret this is the f is its name. This is called the f function. Now, I just made it up. The f function could be something different tomorrow. So this is the f function. X is the variable, the input variable. Okay. And this is the rule that we're going to follow. So when we say f of x, f is the name of the function. Like I'm Foster, that's my name. Okay. Or if I was talking to the students, if I talked to you guys and said, hey, you guys wouldn't know who the heck I'm talking about. But if I said, hey, Marissa, you guys would know who I'm talking to. It's your name. So if I told everybody to look at the f function, you'd all look here. Okay. So how do we use the function? Okay. Let's take f of x equals 5x minus 7. The first thing we write is something like f of negative 3. That's how you say it in English, f of negative 3. And literally what you're doing is you're going to take negative 3 and plug it in for x. So you come over here and you say this is 5 times negative 3 minus 7. And you do your arithmetic and you end up with negative 22. 5 times negative 3 is negative 15. Take away 7 is negative 22. So this function, this rule has taken negative 3 and changed it into negative 22. That's all that's happened. F of negative 3 became negative 22. It took the negative 3 and changed it into negative 22. Mathematicians, because they're fancy, will say something like this. Instead of using the arrow, they'll write negative 3 comma negative 22. They'll write an ordered pair like that, telling us that when we started with negative 3 and plugged it into our rule, we ended up with negative 22. Okay, let's take a new function. Let's make up g of x. Oh, actually, you know what? Forget it. Let's make up g of r for a new variable. G is the name, r is the variable. And what do I want to do with r? Oh, I want to do r squared minus 2r. Now, I just made this up. So here's a new function called the g function. And it uses the variable r. And what does it do? It squares the r and takes away 2 times the r. So what if I said, hey, I want you to find g of -5. Okay, take a second and see if you can figure out g of -5. Now, whether or not you did it in your head or you did it on scratch paper, whatever, doesn't really matter to me. G of -5, we plugged in -5 in place of r everywhere in the formula. So we had -5 squared minus 2 times -5. So -5 squared was positive 25, minus is plus, so final answer 35. So g of -5 became worth 35. That means -5 got turned into 35. Okay, now that's the basics of functions. Okay, it's much more, it gets much more complicated than this, but that's the very basics. We're introducing a rule, and we use f of x or g of r or something, okay, whatever its name is, and we give you a formula. And essentially, you end up plugging numbers into that formula. That's all you're doing. Plug numbers into the formula. And that, well, what we say here with our ordered pair or with our diagram is -5 got turned into 35. -3 on the f function got turned into -22. That's the simplest idea of a function. Okay. What do we have? So, yeah. So what was the f function? F of x was, what did I have?
5x minus 7.
5x minus 7, and we have g, I'm going to make it of x, is x squared minus 2x. Okay, so those are the two functions that I just made up today. In your homework, okay, in the book, on the test, we just make up formulas just for the fun of it. So let's take a second. I want you to find f of 3 minus g of 2. And then I want you to find f of 5 multiplied by g of 5. So those are two totally different problems. This is problem number 1, problem number 2. We'll pause. All right, so number 1, f of 3, that says literally look at the f function and plug 3 in place of x. So this becomes 5 times 3 minus 7. Okay, that's 15 minus 7, that's 8. So f
Where'd
of
you
3,
get 5 times 3?
because in the f function, it's 5 times x. This f of 3 says plug 3 in place of the x number. So the function f of x had 5 times the x. So I'm doing 5 times 3. No, I didn't hear a big aha.
Not yet.
Okay.
No.
Okay. Ouch. All right. Let's look here. If this is f of x, and I say I want you to find f of 3. Okay.
I guess
Literally,
it's just confusing looking at two different equations to solve one. Like instead of just saying like x equals this or this equals that, plug it in. It's like,
well, this says use the f rule and plug in 3. This says use the f rule, that one, and plug in 3. This one says use the g rule, that one, and plug in 2. That's all it says. Use the f rule and plug in 3. Use the g rule, plug in 2. And then
Oh,
when
so
you're
the-
done,
the
subtract.
problem we're trying to solve is the one with the equal sign. And then the one without that is just telling you what variables go where.
Yes.
Okay.
I think.
You would use the formula and then plug in 3 for F, right? And then 2 for G.
3 into f,
Mhm.
2 into g. Yes.
I feel like that's where it's getting confusing. We're not using the formula that
But
get.
but you are. Remember, this is its name. This
Mhm.
is this tells you where to look. It says look at the f formula. And then plug 3 into the f formula. So you're going to plug 3 right here. 5 times 3 minus 7.
Mhm.
So this is 15, take away 7. So this is 8. So literally f of 3 becomes 8.
So are we putting
Got it.
Okay, wait a minute. Are we putting what?
3 at wherever x is?
Yes,
Okay.
yes.
Okay.
Now, the second half of this problem says look at the g function and plug in 2 in place of x. That's the implication. So this is saying g of 2 is 2 squared minus 2 times 2. Because you're putting 2 in place of all of the x's.
I thought
Okay.
you were using R instead of X.
The
Or G.
variable doesn't matter. I rewrote it up here. Doesn't matter. You want to use R? It doesn't matter. It's you're putting 2 in place of the variable. That's all you're doing. You're plugging 2 in place of the x or the r. Doesn't matter. This becomes worth 0. 4 minus 4 is 0. So literally this became 0. So the problem says the f input minus the g input is 8. And that's the end of it. I think you guys are thinking too hard. It's honestly not this difficult at all. Okay, what was the other problem? I erased it up here. It was f of who?
F of 5.
Okay, f of 5 multiplied by g of
5 also.
5.
5, 2.
5.
5, just 5.
5. Okay, so again, after this discussion, you're going to look at the f function and you're going to put 5 in place of x and work out the arithmetic. Then you're going to look at the g function and put 5 in place of x in the g function and work out the arithmetic. And then after you work them both out, you're going to multiply them together. So I'll be quiet for a minute while you work that out if we've talked about it, and then we'll work it out in a second or together. I got something like 260 or something like that. I was just doing it in my head. I don't know. So this time we want to find f of 5 because that's what that says. So it says, look at the f function and plug 5 in place of the variable. So x becomes 5. So this is 5 times 5 minus 7. X became 5. This is 25 minus 7. This is 18. So f of 5 is worth 18. Okay. Now we move to the g function. This time we're going to find g of 5. Again, it says look at the g function and plug in 5 for the variable. Remember, g and f are its names. X is the variable, or r, it doesn't matter. So this is going to be 5 squared minus 2 times 5. 25 minus 10. 15. So g of 5 turned into be 15. But I'm supposed to multiply these together. 18 times 15, is that 220?
270 is what I got.
270 is what I got.
270, okay. Well, then don't trust me to do things in my head. Okay, it's just a fancy way of us getting you to do arithmetic, plug in an arithmetic. You feeling a little better? You want to do a couple more of these just to make sure you got it?
If we can,
Yeah,
yeah.
can we do more? And then
Okay.
can we write the, you know how like one equation correlates to the other? Can you write it right above it whenever we do them?
You mean like right here? Can I put these steps right here?
Just like, yeah, I guess I think it's the how spread about everything is. It's confusing me.
For me, it
Okay.
just didn't click to use the function when you first wrote down the problems. So it kind of just threw me off. Yeah.
Okay.
I
Yeah, this tells you where to look.
Mhm.
And this tells you look at the F, plug in 5. This tells you look at the G, plug in 5. But let's make up whole new functions, totally new ones. Okay, totally new ones. Let's make up, an H function, H of X. What do you want to do with it? Let's say it's X plus 3 divided by 2. That's the H function. I don't know. Let's make up another function. Let's make up the L function, L of X. Make up the L function. And we'll make this one nice. We'll make this 2x plus 5. Again, we just at the beginning, we just make these things up. H and L, those are the two functions instead of F and G. Okay, so I want you to find H of 7 plus L of -3. H of 7 plus L of -3. Okay, let's go ahead and do it. I did it in my head. Again, you guys saw how I screwed up over here. I think I got -4 for a final answer. But let's see what happens.
Got 4.
Yeah, I
Four,
got
four,
Positive
you're right,
four.
4. Okay, so H of 7. That says, look at the H function, plug in 7. So that would become 7 plus 3 over 2. 7 plus 3 over 2. That's 10 over 2. That's 5. So h of 7 turned into 5. Now we want to find L of negative 3. So this says, look at the L function and plug in negative 3. So this is 2 times negative 3 plus 5, because that's what the L function says. So this is negative 6 plus 5. This is negative 1. So L of negative 3 turns out to be negative 1. But then the problem says, whoops, I want you to add these two answers together, because it was to take this answer and add it with this answer. So 5 plus negative 1 is 4. And that's the final answer. Feel a little bit better?
So
Yes.
Okay, a little bit better. I was going to do more on functions. I'm going to wait till tomorrow night. That I don't want to confuse you with more. There's a lot more we have to talk about. I'll wait. Okay, that's the first concept of what is a function. A function is a math rule. Here's the rule that changes the value of the input number. If we input 7, it got changed into a 5 in the H rule. In the L rule, if we input negative 3, it got changed into a negative 1. Okay, that's the most basic
so how will,
definition. Go ahead.
I was just gonna say, how do you write your answer once you get the number? You just write it below everything, or do you like?
Okay. Okay. Usually, you write it. Okay. Let's assume that I just asked you to find one problem. Let's assume that I said, I want you to find h of negative 7. That was it. Just find that. Okay. So you say, this says, look at the h function, plug in negative 7. So you say this is negative 7 plus 3 over 2. This is negative 4 over 2. This is negative 2. Now, typically you write this, you say, oh, h of negative 7 is negative 2. The h changed negative 7 into negative 2. That's it. That's how you write it. Mom would probably just have you write negative 2. The answer.
Thank you.
That's it. Okay. Now, you said thank you, but do you really mean it, or you understand? You okay?
No, I understand that. I just needed to, like, I don't know, have a way to write it, I guess.
Okay. This is better, but this is what mom will accept, and this is what most people will accept. Just the answer. If I plug negative 7 in, what's the answer? Negative 2. Bingo. That's it. Okay.
So when we get a question on the function, are
Yeah.
we going to get the rule, or we have to create our own rule?
That's a really cool question. At the beginning, we will always give you the rule.
Okay.
Okay. But as we move through the semester and you get more skills and more practice, then we'll ask you to determine the rule. For example, okay, don't panic. Don't panic. We might say, hey, if h of 3 is 9 and h of 5 is negative 1, what's the rule for h of x? Okay, but that's much further down the line. we would give you hints. We would say, hey, when you plug in 3, you get 9. When you plug in 5, you get -1. Can you come up with a math rule that works for all of this? Okay. And I'll show you how to do that. I'll walk you through that. I'll teach you how to do it. But right now is I will always give you the rule, and all you have to do is plug in and do arithmetic right now. Okay.
Okay.
That was really good. You guys are asking really neat, thought-provoking questions. I like that. Okay. Anybody else? Okay. That was the concept of a function. And again, we'll extend it a little bit more tomorrow night. Remember, tomorrow night, I'm going to quit around 8 o'clock, roughly. And you'll have the quiz. The quiz will be timed. You'll have 1 hour, but you must be finished by midnight. So again, you can start at 11 o'clock and finish it at midnight. You can start at 9:30 and finish it at 10:30. I don't care. As long as you're done by before midnight, I'm happy. But you'll have 1 hour to do this quiz. You don't have to show me any work. You don't have to do diddly squat. Just put the answers in Mom. That's all you're going to be doing tomorrow night. But
How
it's
many
not,
questions?
I want to say 20, but some of them are real short, like round this problem. I mean, those don't take forever to do, you know, add like terms, that kind of thing. Those are really short. So even though 20 may sound like a lot of work or several problems, some of them are just real quick. So don't
Thank you.
panic. Okay. All right.
Mom is gonna show us our score at the end, or
I'm sorry, say again.
Mom is gonna show us our score at the end, or which ones
Yeah,
we got
it'll-
right,
it'll-
which ones we got wrong.
Afterwards, yeah. It won't tell you, it'll say you got it right or wrong, but it won't give you a chance to go back.
Okay.
It may give you a chance to go back one time, but it won't give you a chance to go over and over and over. It says you got this one right, you got it wrong, move on to the next one. I think I've got it set. I hope I've got it set so that you can look at all of the problems and you can do the easy ones first. I'll double check my settings, but that's the way I like to write my quizzes. So you can see all 20 questions. And then
Okay.
you always do the easy ones first, guys. In a math test, always do the easy ones first. Get those points. Okay. And then work on the next easiest. Get those points. And lastly, spend time on the really hard ones. And if you're running out of time, you ran out of time. But at least you got the points for the easy ones. That's the critical thing. So in math, and I believe I set this up so you can do it, okay, always skip around. Never do things in order. Okay, get the easy points first. Okay, here we go.
Thank you so much.
Yep, chapter 4.1. Okay, we're going to talk about the coordinate, which I can't spell, coordinate system.
Professor, you said you were going to talk about the 3 views of the functions.
Yeah, I decided I'm going to push that till tomorrow because you guys, I don't want to confuse you more tonight than I already have with functions.
Okay.
So I'll pick that up tomorrow. Okay, so totally separate concept. The coordinate system. Most of you guys have seen it in the past. This is called the x-axis. This is called the y-axis. Axis is just a fancy word for line. And what these are actually number lines. This is 1, 2, 3 on the x-axis. This is -1, -2, and so on. And they go on forever and ever. Okay. And on the y-axis, again, this is 1, 2, 3, 4, and it goes up forever. And just because my graph doesn't go up It does. If I said graph 5, it's there. Okay. And down here, these are -1, -2, -3, and so on. So this is called the coordinate system. Some people call it the XY coordinate system. Okay, whatever. It divides the whiteboard or the plane into 4 sections called quadrants. Quadrants, Quadrans. Okay, and we always label the quadrants with Roman numerals. Anything else is wrong. The quadrants are labeled with Roman numerals. Now, some people call this Roman numeral 1. Some people call this Q1. Okay, and I forget what mom does, whatever. But this is called quadrant 1. This is called quadrant 2 or Q2. This is quadrant 3, and this is quadrant 4. And they're always labeled with Roman numerals, though I, II, III, IV, and they're always labeled in this order. And if you ask me why is this 1 and this 2, I haven't a clue. I really don't know why it labels in a counterclockwise direction. It just does. Okay, those are our quadrants. Okay, then the next thing that happens is in our quadrants, we want to label what are called ordered pair. Ordered pair. Now, the word ordered literally means that the order matters of 2 numbers, the ordered pair of 2 numbers. Okay. In symbols, we call them X, Y. But an example of that may be 2, 5. And we always start from right here. That's called the origin. Now, this is all in the book if you want to read it. This is all should be a little bit of review for most of you. We always start here, and we always do the first number represents movement along the x-axis. So this says move 2 places along the x-axis, 1, 2, and then go 5 places in the y direction, 1, 2, 3, 4, 5. So right up here, this point is the ordered pair 2, 5. And I'm going to erase the green things there, but that's what you're thinking. You always start at 0, 0. That's what that point is. It's called the origin. It's the starting point. And you always do X first and then Y. Never the reverse, ever, never the reverse. X is always first. So from the origin, you go over 2 in the X, 5 in the Y. And this is called plotting the point. Plot or graph. Okay, they can't make up their minds, the point. Okay, so again, new vocabulary. An ordered pair is also called a point. Okay, so we have all of this vocabulary that's all just different words for the same thing. An ordered pair is called a point, or worse, it's called a coordinate. So we have all of these crazy vocabulary words, okay, to mean the same thing. So this is the, look where I'm pointing, this is the ordered pair 2, 5. This is the point 2, 5. This is the coordinate 2, 5. They're all the same. Notice they always have a parenthesis around them. always. So when you're talking about a point or a coordinate or an ordered pair, it always has a parenthesis around it. Always. That will never change. Okay, so a lot of the homework on Mom on this first section is going to ask you, okay, to plot these points. A might be 5, 1. B might be 7, -3. C might be 0, I don't know, 4. Okay, so take a second on your own graph, okay, roughly plot those. I'm not looking for perfection, guys. Put those on your graph and label them with A's, B's, or C's. Does the orange show up? I know it didn't the other day, but I have a new pen. Okay. 5.
I think that color's still a little hard to see.
Still hard to see. Okay, then I won't use it. Yeah, I can see on the screen it's not. So I'm not going to redraw it right now, but A is out here. You go over 5, up 1. That's point A. Okay. B went over 7, down 3. That would be point B right about there. And if you came close, I don't care. Don't worry about accuracy right now. C, okay, confuses people. The X is 0, which means if we start here, we don't move from here. Remember, we always start here. So it says don't move in the X direction. So stay there in the X and then go up 4. That would be point C. Okay. Is that all right with everybody?
Yeah.
Okay. Then let's go a couple more things. I'm going to just fake this. This is D. This is E. Okay. And this is F. D here, E here, F here. I want you to give me the coordinates of points D, E, and F. Give me the coordinates. So D, E, F. What are their coordinates? I'll give you a second to think it out. Okay, now your answer may be slightly different than mine because your scale on your graph might be different than mine. But as long as we're close, I'm happy. So anybody want to take a shot at D? What do you think D is?
-2 and 1.
Yeah, okay. And somebody could say, no, I've got -2 and 1.2. Yeah, okay, I understand that. Did you use parentheses? That's important.
Yes.
Okay, got to use,
Yes.
okay. Anybody else want to take E?
0, -4.
Yeah, I'll take that. That would be perfect. And F, anybody?
0,
0, 0, 0.
0, 0. You got to have 2 numbers there. I heard it twice. Okay, so that's the first part of section 4.1 is just a quick introduction to the coordinate system. Okay, and that's the questions mom's going to ask you. She's going to ask you questions about what are the quadrants. She's going to ask you to plot some points, and it takes a couple minutes to learn how to plot things on Mom. You're going to have to read the directions. Okay, to plot them, you click on the dot and then you go to the correct spot and then click on that spot. Okay, but read the directions. It takes you a while to practice that, but that's why we have that assignment. And then she's going to put some empty dots around and ask you for what are their coordinates or their ordered pairs. The big thing is the vocabulary. An ordered pair is also called a point, is also called a coordinate. Those three words all mean the same thing. So sometimes you'll see the problem will say graph the ordered pair. The very next point problem will say graph the coordinates. And the next one will say graph the point. Okay, they're all synonymous. All right, still in section 4.1, new concept. Can I erase my graph?
Yeah.
Everybody's happy with that?
Yes.
Okay. Okay. So we're going to talk about something known called a linear equation. Linear equation in two variables. Or instead of the word in, maybe with two variables. An example of that might look like 2x plus y equals 6. Okay, this is, I'll explain what the linear means in a minute, but this is an equation in two variables. Now, a solution to this, if we say find a solution, it equals an ordered pair that makes it true. So if I give you some linear equation, 2x plus y equals 6, and again, I just made that one up. My next example might be something totally different. Okay, and I ask you for a solution, your answer would be an ordered pair that makes it true. So for example, is 3, 0 a solution?
Yes,
Okay, how do you know?
because it equals 6.
Okay, because when you plug it in, you go 3 goes in the x place. Remember, the first number is always the x, the second number is always the y. So when you plug this in, you have 2 times 3 plus 0. 2 times 3 plus 0. Does it equal ? 6? And the answer is yes. Okay, so is it a solution? Yeah. Is that okay with everybody? Okay. What about 5, -4? What about 0, 6? What about 2, 3? Try those. Just put yes or no. Are each one of those a solution or not? What about 5, -4? Is that a solution?
Yes.
Yes.
Yes. What about 0, 6?
Yes.
Okay. What about 2, 3?
No.
No. Okay. All right. First question to everybody is does everybody accept my yeses and nos for these top 3 are solutions? These bottom one is not. Are you guys okay with the arithmetic?
Yes.
Okay.
Yes.
And there's a big glare in the middle and
Yes.
yeah, okay, whatever. Sorry. Okay. So now this leads us to a really important fact. A linear equation in 2 variables has an infinite number of solutions. Okay, think about that. An infinite number of solutions. There's an infinite number of ordered pairs that we could find that make that one true. There's also an infinite number that make it false. Okay, an infinite number of solutions there for that one. Okay, that's going to cause us issues. Okay, so one of the things we ask students to do is we ask you to find 3 solutions. And I'm just going to make up an easy problem. X plus Y equals 7. Find 3 solutions. Okay. And the typical way we teach this is we build what's called an XY table. And we randomly pick any number you want for X and plug it in. Okay. So 3, random. I just pick an X. 3, plug it in. 3 plus Y equals 7. So this is plug in. You could probably solve that in your head. What's Y?
4.
4. So Y is worth 4. So the solution is 3, 4. I'll get out of the way in a second. So how did I start this? Well, first off, I just made up an equation, a linear equation in 2 variables. I just made it up. And I said, find 3 different solutions. So question, where did this 3 come from?
Your
My
imagination.
Random.
Random. I just made it up. Random. Picked it out of thin air. Anything I want. But then I plug it in and I use my algebra skills to solve it. Now, that was pretty easy. I could solve that one in my head. Others, not so easy. Okay, others are not so easy, but I could find it. I got a Y value, so my solution is the ordered pair 3, 4. Okay, now, I said find 3 of them. Okay, I want to clue you in on something very, very important. Mathematicians are lazy. We're the laziest people in the world. So if we can plug in easy numbers, we always do. So suggestion.
X equals
If you
4.
ever, well, yeah, that would be a good one too. That would be a good one. But always try to use 0 if you can. Always try and use 0. You can pick any numbers you want. No one's going to stop you. But we're being lazy now. Plugging in 0 for X is real easy problem to solve. So we have 0, 7.
1 is pretty easy too.
Okay, except I'm going to ignore you because there's a hidden thing. Who says you have to start with X? Why can't you plug in for y? Think about that. Why can't you start with y? Nobody ever said you had to start with x. So why can't we plug in 0 for y if we're going to be lazy? Now, okay, was that Mitch was talking about 1? I couldn't see your name. I just tried to recognize your voice. Okay, yeah, that would have been fine. Would have been perfect. It would have been just great. But I'm trying to push laziness and I'm trying to push some of the tricks. Okay, always, if you can, plug in 0 for x and figure out y, what the y value is, and then plug in 0 for y and figure out what the x value is. If you can, because it's much easier. So if we do that, if we plug in 0 for the y, we have x plus 0 equals 7. So that means x is worth 7, and we have 7 comma 0. And now we have 3 solutions. Now, Mitch, you said 1 for x, that would be 6, so 1 comma 6. There's an infinite number of solutions, okay, that you guys can pick. But I'm trying to get you guys to think kind of like a mathematician. You want to be lazy. You want to pick the easiest numbers possible. 0 for x, plug it in, get y. 0 for y, plug it in, get x, and then one more number. Okay. Let's have you guys (3x minus 2y equals negative 12). I want you to find 3 solutions. 3 solutions. All right. So, okay, if I follow my own advice, I'm going to start with 0 for x, and I'm going to plug it in. 3 times 0 minus 2y equals negative 12. 3 times 0 drops out, so negative 2y equals negative 12. I can solve that in my head and get y is 6. So my solution would be 0 comma 6. That's one of my solutions. Okay, whoops, ordered pair. Now, another solution, again, following my own advice, we picked 0 for x, I plugged it in, got a y value. Now I want to pick 0 for y, plug it in. So that's 3 times x minus 2 times 0 equals negative 12. That becomes 3x, 2 times 0 drops out, equals negative 12. Divide by 3, I think you guys can do that in your head. You get negative 4. So my solution is negative 4 comma 0. Again, remember, even though we started with 0 for y and work back to find x, our solution is always x comma y. X comes first in our solution. Okay. Did anybody pick any numbers other than 0, other than what I have up here? Anybody pick another number?
2.
2 for who? For
For
y?
For x.
For x? Okay. 2 for x is 6. Negative 9 or 9. I get 9. Let's see what happens. 3 times 2 for x minus 2y equals negative 12. Oops. So this is 6 minus 2y equals negative 12. Okay, got to use a little algebra here. I got to take away 6 from both sides. Minus 6 minus 6. Okay, it gives me negative 2y equals negative 18. So dividing both sides by negative 2, I get 9. So my solution is 2 comma 9. Is that what you got?
Yes.
Okay. Anybody else come up with one? Okay.
1 for X.
1 for X. So you got what, 4.5 for Y? No, 1 for X, 15, 7.5 for Y?
Oh, I got 8. Maybe I did it wrong.
Yeah, you did. Okay. Okay, erase this. We'll do this one. So you said 1 for X. Okay, so if X is 1, we have 3 times 1 minus 2 times Y equals negative 12. Well, 3 times 1 is 3. So that's 3 minus 2Y equals negative 12. Subtract 3, and we get negative 2Y equals negative 15. So when we divide by 2, we get 7.5 or 7.5. So it should have been 1 comma 7.5. Okay, so double check your arithmetic there. All right, I want to go to a slightly different problem. Okay, here, this is a basic idea. This is still all in the first section of chapter 4. Okay, given some kind of equation, can you find 3 solutions? Now, sometimes, guys, you can do this work in your head. Okay, and the only thing we need to see is 0, 6. Okay, so I don't know. The table is a really nice thing. If you can do some of it in your head and some of it on table, that's cool. But make sure I know where the 3 solutions are when you do that, or mom knows where they are. Okay. A slightly different equation. Okay. Sometimes we'll write our equation as y equals 3x minus 5. So instead of having x and y together, we can have the y by itself. Y equals 3x minus 5. But we can still ask the same thing, okay? Find the solutions. Now, okay, all right. I'm going to ask you, maybe I'll just be quiet and let you guys work on this for a couple minutes. I want you to find 3 solutions for this. Okay, turns out Foster lied to you. Not really, but I kind of did. All right, first thing we can start with 0 for x. That's easy, so we plug it in. So y equals 3 times 0 minus 5. So y equals negative 5. And so our solution, I'll get out of the way in a minute, is 0, negative 5. That was pretty easy. Okay, when x was 0, plug it in, do your arithmetic, you get y is negative 5, we get a solution. But I encouraged you to also plug in 0, y is 0. I tried to get you to do that. You could yell at me at this problem. You could say, that's a pain. I don't want to do it on this problem. Okay, I'm going to work it out just so you see the work. But you could also argue that plugging 0 for y is kind of more difficult on this particular problem. So you choose not to do it. Okay, I just told you to be lazy if you can. But let's try this. So this is, if y is 0, so we have 0 equals 3x minus 5. Oh, how do I solve that? Add 5 to both sides. So I get 5 equals 3x. Divide both sides by 3. And I get 5/3, which is also 1 2/3. I don't care how you write it, it doesn't matter to me. But a solution is 5/3, comma 0. Whoops. Okay. So there's an answer, although it got me fractions, and so I'm kind of lazy. I don't like that. Probably, let's pick x is 1. Why not? Because see, y is by itself. So in this problem, it would be easier for me to pick x values. I should have thought of that. So this is y equals 3 times 1 minus 5. That's 3 minus 5 is -2. A solution is 1 comma -2. Did anybody pick any other numbers just for trying these?
I used 5 for x.
5 for x. So if x is 4, so y is 3 times 5 minus 5. So that's 15. Take away 5, you get 10. So 5 comma
Yeah.
10. Good. Okay. Anybody get a different answer? Okay. So I'm going to assume by the silence that you guys are all relatively happy with finding solutions. It's just a bunch of arithmetic. You just pick x values, plug it in, do your algebra, and get a y answer. Or you pick a y value, plug it in, do your algebra, and get an x answer. Okay, that's all finding solutions are. You just randomly pick x's and y values and plug them in. You try to be lazy if you can by picking x is 0, plug it in, and then y is 0, plug it in. You try to be lazy, but you can't always do that. So the thing is, I got one more kind of topic that I want to do, and I want to tie it to this. Why do we do this? Just to prove to you that a linear equation has infinite number of answers, and we're finding 3 of them? That seems kind of silly. Okay, yes, a linear equation in 2 variables has an infinite number of solutions, and we've only found 3 of them for each one of these problems. So what? Well, we use these to graph the line. And you're going to have to practice. I think some of that practice test was practice graphing lines. So if, let me erase this, and this will be the last topic of the night, and we'll get out relatively early again. I'm going to take an easy problem to work on tonight. We'll get more difficult tomorrow. But suppose I told you that I want you to graph, we'll take an easy equation, 2x plus y equals 6. Okay, 2x plus y equals 6. The first thing you do is you find 3 solutions on a table. Okay, so x, y is 6, so our solution is 0, 6. If y is 0, x is 3. Trust me, I never make mistakes. Just trust me, I'm doing it right. Okay. If x is 1, I think y turns out to be 4. So 1 comma 4. Okay. So again, I'm going through this quickly. I just picked x was 0, plugged it in my head, got y was 6. There's my solution. Then I, in my head, said, hey, if y is 0, I plugged it in my head and got x is 3. Now, many of you will have to do a big full-on table with lots of scratch work. That's okay. Right now, for time, I'm kind of speeding up a little bit, skipping some of those intermediate steps. Then I picked if X was 1, okay, solved it, got Y was 4, there's my solution. So if I said to graph this, the first thing you want to do is find 3 solutions on a table. The next thing you want to do, second thing, is you want to plot the ordered pairs. On an XY axis. So you plot 0, 6. 1, 2, 3, 4, 5, 6. 0, 6. 3, 0. 1, 2, 3. 3, 0. 1, 4. Kind of like that. Okay. So again, let's go back. I want to graph this. First thing I do is find my 3 solutions. Second thing I do is once I have my 3 solutions, I plot their ordered pairs on an XY axis. Now, we need to talk some theory for a second. Remember, I called these a linear, L-I-N-E-A-R equation. I called this a linear equation because the root word is line, linear. If you plot these 3 points, do they make a straight line? If they don't, you screwed up somewhere. Linear equations graph as straight lines. We found our solutions. We plotted the ordered pairs from the solutions here. Do they make a straight line? I think so. Okay. So look at how we draw that straight line. We draw it through all of the points, and it has an arrowhead on each one. Okay. Again, some math philosophy, some math theory. How many solutions does a linear equation have?
Infinite.
Infinite. We have only found 3 of them. The line is a visual representation of the infinite answers. Okay. Why? Well, if you took your microscope and you zoomed in on this, you would see that this line actually is an infinite number of little dots, ordered pairs. An infinite number. And if we did an infinite number of solutions here, they would all make this line. But again, mathematicians are lazy. So in order to graph something, we get 2 or 3 points, we connect the dots, and we say the line is the representation of all of the infinite solutions I was too lazy to find. The line represents the infinite number of points, of dots, that I didn't find. I only found 3 of them. Okay. You're going to have to work with mom when she says to graph something. She will probably say use just 2 points. 3 is better. You're going to have to kind of figure out in mom, it's a little bit weird, but once you figure it out, it's just not that hard, how to graph the 2 points, put dots there, and then it'll ask you to draw a line through the dots. So it's kind of easy. You pick it. It's hard for me to talk to you right now. Maybe tomorrow we'll do a little exercise on mom. Questions? Then I'm done for the night. See you guys later. See you tomorrow night. Bye-bye.
Bye. Thank you.
Thank
Okay.
you.
Bye-bye.
Bye. Thank you, Professor.
Professor.
No
Good night.
attendance, Professor?
No, not tonight. I'm tired.